And welcome back. As we go ahead and get ready to look at our next concept, which is that of abstract classes. Now, abstract classes come up when we start wanting to compare across classes. So let's say previously, when we looked at this already, we say, hey, we have an employee and we have its derived classes such as hourly employee, salary employee, etc. And let's say when we define the class employee, we want to know, hey, we're frequently going to look at the employees, for example, and say, hey, do you have the same pay rate? We're going to maybe do some pay comparison or something like that. Well, we say, well, you know what? We could add a method for that to make our life simple. Let's say we have a method called public boolean same pay, employee other, return this dot pay equals other dot get pay. Seems simple enough, right? If it's a boolean method, it's going to return true or false. If it's true, they have the same pay. If it's false, they don't. And this seems pretty simple enough. However, there is a small issue. If we look at the method samePay as it's currently written, it includes an invocation of the method getPay, and the class employee has no getPay method. And if you think about it, there's no reasonable definition we could give to getPay that we could add to the class employee, because if we start thinking about it, for example, our salary employee is going to be a very different pay schedule than our hourly, which would be different from like if we had a commission employee. The only instance variables in the class employee that we can rely on are the employee's name and their hire date. And there's nothing in there about pay, right? We have no information about the pay for an employee. And because of that, well, we don't know how to define get pay until we know exactly what type of employee we have. Are they hourly? Because that's going to be an hourly rate. Are they salary? Because then we can just compute a monthly amount, etc., etc. Well, this means we're going to kind of want to postpone that definition of get pay and give it only in each derived class of employee. So only hourly employee would have get pay. Our salaried employee would have get pay. And the way we're going to solve this, though, is with something called an abstract method. Abstract methods are going to allow us to work with the things that we look at this problem as like, well, how do I know what kind of class I'm going to have? Well, an abstract method, and we look at it, it has just a heading like an ordinary method, so just all the same things we would expect to see in heading. However, there's no method body. The syntax rules of Java require the modifier abstract put in and require a semicolon place the missing method body, such as below: public abstract double get pay. Seems simple enough. Well, if we add this abstract method to get pay to the class employee, then we're free to add this method same pay that we previously wrote to the class employee, because now get pay exists. Now, there are a couple things that we have to keep in mind here. First off is that the abstract method cannot be private. All right, the best way to think about this is it's part of the interface of a method with all the implementation details taken out. All right, because a private method normally is only a helping method and so is not part of the interface for a programmer using the class, it follows that it doesn't really make much sense to have your private abstract method. Now, in Java, it's in fact, abstract method cannot be private. Normally, the abstract method would be considered either public or protected, and package access is allowed as well. Now, with the abstract methods, they have a goal, they have a purpose, even though it's not necessarily going to give us a full definition within our starting class here. It instead is think of it more of as a placeholder for a method that has to be defined in all non-abstract derived classes. An abstract method has a complete method heading with the addition of the modifier abstract. Now note the abstract employee class, the method samePay includes invocations of the method getPay, and if the abstract method getPay were omitted, well, the invocation of getPay would be illegal. Now with an abstract class, this is a very similar approach. All right, the biggest thing to know with an abstract class is that it's a class that has at least one abstract method. Pretty easy to remember. And of course, modifier abstract has also to be added to the class heading, not just to the method heading here, but also to the class heading. So an abstract class can have any number of abstract methods. An abstract class has typically one or more abstract methods, and it typically has also our regular or fully defined methods. Now, if in a derived class of an abstract class does not give full definitions to all the abstract methods, or the derived class as an abstract method, then the derived class is also an abstract class and must include the modifier abstract in your heading. So you notice, like if we were to say, hey, hourly employee, we're going to have, for example, a full-time employee and a part-time employee. Well, maybe we need to have some abstract methods for that. That's a good way to go ahead and start using some of that, where you can have not just your base class, but your derived classes have, because those derived classes may also be abstract for the methods or the classes that follow them. Now, in contrast with the term abstract class, a class with no abstract methods, so the ones we're very familiar with, are what are known as concrete classes. Now, there is a pitfall to be aware of, and that's you cannot create instances of an abstract class. With your concrete classes, yeah, it's pretty easy to do, but with the abstract, you can't. All right, you cannot use an abstract class constructor to create an object of an abstract class. You can only create objects of the derived classes of the abstract class. So with an abstract class employee, the following invocation would actually be legal. Employee Joe equals new employee. All right, we used to be able to do this, but if we make it an abstract, we can't do this because it's an abstract class. Now, technically, this is a problem because the object Joe would not correspond to any real-world employee. And any real-world employee, of course, it's not just employee, but really, if you think about it, they're a type employee. What role are they playing? Are they full-time, part-time? Are they commissioned? Are they an administrator? Therefore, we can compare employees to see if they have the same pay, even though the way of calculating it might be different for the two employees. All right, and lastly, let's leave you with a quick tip that an abstract class is a type. All right, you cannot create an object of an abstract class, as we already mentioned, unless it's an object of some concrete descendant class. So, for example, if we had employee was the abstract, and let's say hourly employee was abstract, but let's say full-time employee was not. Well, full-time employee would be a concrete descendant class. Nonetheless, it makes perfectly good sense to have a parameter of an abstract class, such as type abstract employee. Then, an object of any of the descendant classes of employee can be plugged into that parameter. It even makes sense to have a variable of an abstract class type such as employee, although it can only name objects of its concrete descendant classes. You can't, for example, have employee descendant classes and try to pass in like a super date in for an employee, because it's not the same type. It doesn't follow the same hierarchy. All right, and if we just pop over to clips real quick, we can see some examples of how that abstract is working here. So you can see we have our public abstract double get pay, and you'll notice again we don't have the method fully figured out here. We don't have any of this stuff here. It would be inside the body of a method. All right, none of this is here. It's simply just ending with a semicolon. So just like we're doing a method stub here. In fact, that's effectively what we got. It's just a little method stub. Now, you'll also notice that we have the keyword abstract for the modifier up here in the class definition. All right, this is the only abstract method that we have. It's just this one. In fact, if I try to take out, though, this abstract class here, you'll see we get an error here. And it's saying, it has to be an abstract class if we want to have an abstract method, because that's just part of how this works here. So anytime you have an abstract method, you're going to make it into an abstract class. So it's a real easy way to kind of approach how do I get these things together. And if I take out this here, take out this one, you'll notice now we get an error, all right? Because now it's like, hey, it needs a body here instead of a semicolon. If I can put a body in here, no big problem. And then it's like, what do you mean? It has to return type double. Okay, well, let's just say we return, 0, just to satisfy this. And you see it will compile here. However, the issue is not so much this. It's like now when we actually try to use get pay into our other methods, such as down here, we are going to run into the issue. So that's why we have to make sure we keep this as a abstract here, because then this is again going to be used in like hourly employee, salaried employee, etc., to actually get the information that we want to use here, instead of trying to do some convoluted way of trying to jump over different hoops and things to actually get code that we want.